Hello friends, welcome back to the YouTube channel STD Math Class. After a long time of period, I am making this video. So in this video today we are taking the topic the area of parallelograms and triangles of standard line. Actually this chapter Cbse deleted from the course or syllabus. But this year, this chapter is again included in our 9th class syllabus. For that, so many students request me to make the video about this chapter. So, today I am getting some time to make a video for that chapter. It is the area of parallelogram and triangles of standard line. Okay? So, this chapter, this video, today we will discuss about the theorem 1 of this area of the parallelogram and triangle chapter. Okay? See, here the theorem written, theorem 1, the parallelograms on the same base and between the same parallels are equal in area. It is the theorem, parallelograms on the same base and between the same parallels lie are equal in area. It means if two parallelograms lie on the same base and between same parallels, then their areas will be equal. That thing we have to prove in this video. For that, first we have to draw the figure. First we have to draw the parallelogram. It is a parallelogram, already know. In a parallelogram, we know that in a parallelogram, the opposite sides of the parallelogram are equal. Here, we will draw. It is the parallelogram. Its name is, we taking the name, it is A, B, C and D is a parallelogram and AB, EF is another parallelogram. Here two parallelograms are there. One is ABCD parallelogram, another one is your ABEF parallelogram. These two parallelograms lie on the same base AB and between the same parallels DE. Then we have to prove that the areas are equal. Okay? So, now we prove. For that we have to write the given. What thing given here? Given. First, we have two parallelograms ABCD and ABEF. That we will write first. Here ABCD and ABEF are two parallelograms. Parallelograms. Two parallelograms having same base AB and lie between same parallels AB and D. Okay, it is the given part. So ABCD is a parallelogram and ABEF another parallelogram. See which is parallelogram I am saying? One is your ABCD, this one. ABCD is a parallelogram. This one the parallelogram. Another one is your another one AB, this one. Okay. So, these two parallelograms. One is ABCD parallelogram, another one ABEA parallelogram. These two parallelograms having the same base AB and they lie between the same parallels AB and DE. It is our given. Then to prove. First thing we have to prove. We have to prove that to prove what will prove here? The area of parallelogram ABCD is equal to area of a parallelogram ABEF. We have to prove that area of parallelogram ABCD and area of parallelogram ABEF both are equal. That thing we have to prove. To prove this theorem, we have no need of construction. So, no need of construction here. Directly, we will go for the proving part. Okay. To prove one theorem, we have some sequence. First, we have to write the statement. So, the theorem written here, it is the statement. After that, we have to write the given part. Then, to prove, then we will go to for the prove part. If the construction required, then we will construct it. Otherwise, directly we have to go for the proving part. Okay. Now, in this theorem, there is no need of construction. So, directly we will go for the proving part. Okay. Given complete, to prove complete. Then, next thing is our proof. Okay. Yes. Now, we will prove it. We need the figure, so we have to draw the figure again, because in that side that's the slide the figure went, so we have to draw the figure again here. It is a parallelogram, first we draw. Yes, this one the parallelogram, another parallelogram here. So whose name is its name is A, B, this one we got C, and this one D, and it is E, and it is F. A, B, C, D, E. Okay. Now, one by one we prove. Proof first we have ABC is a parallelogram. ABCD is a parallelogram. We know that. We already know the proof properties of the parallelogram. In a parallelogram, opposite sides are equal and parallel. Okay. When ABCD is a parallelogram, we got that AB parallel to CD or DC. AB parallel to DC got. Next, and AB parallel to BC, because opposite sides are parallel. So AB parallel to BC and AD parallel to BC. We need here AD parallel to BC. Okay. So right here AD parallel to BC and DE is the transversal. DE is the transversal. DB is the transversal. Which one? For that I am showing another figure I am drawing here. It is these two lines are there and like that one transversal is there. So what is called transversal? Previous videos we already discussed about it. When a straight line intersect two or more parallel lines or two or more lines in distant points, from different points, then it is known as a transversal. So here AD and BC, two parallel lines. Then this one, this part is the transversal. Okay. Now we know that when the AD parallel to BC, suppose it is A and it is B, and it is B and C, AB and CD. These are two parallel lines, and BC is the transversal. When a transversal intersect two parallel lines in different points or distinct points, then their corresponding angles are equal. Corresponding angles are equal. It means we are getting that this angle and this angle are equal. So ABC angle and B is this angle, and between 1 and 2, these two angles are equal getting. Like that, in our figure, we will get this angle and this angle are equal. Which angle? The ADF angle and BCE angle are equal. Okay? That part will write first. When AD parallel to BC and B is the transversal, then you will get that angle ADF is equal to angle BCE. So what is the relation of these two angles? These two angles are known as your corresponding angles. Okay? So why they are equal? Not because corresponding angles. Corresponding angles. Because these are the corresponding angles. Like that, again we will take another triangle, another parallelogram. In parallelogram ABEF. In ABEF, which is being parallel? AF parallel to BE. Okay? AF parallel to BE. This one. AF, this part, parallel to BE. This part. Okay? AF parallel to BE. When these two are equal, or sorry, parallel, and also equal, because in the parallelogram opposite sides are equal also. And same, DE is the transversal. DE is the transversal. Then what will you get? You get that AFD angle. AFD angle is equal to BEC angle. BEC angle. Okay? AFD angle. Which is angle? AFD, this angle, and this angle. These two angles are equal. AFD angle and BEC angle are equal. Why equal? Same, because the corresponding angles. Reason what? Why they are equal? The corresponding angles. Corresponding angles. Okay? When you prove, we have to write the reason. Why they are equal and why we are equaling them, we have to write the reason. So, why they are equal? Because of the corresponding angles. Okay? Now, you see, in triangle ADF, this triangle, see, in this triangle and this triangle, in these two triangles, see, what thing you have? Here, angle D equal to angle C and angle F equal to angle E. And we know that in a parallelogram, opposite sides are also equal. Okay? Then what we will do? We have to congruent these two triangles. ADF triangle and BCE triangle, we have to make them congruent. Getting my point? Okay. Next we will go for the congruent part. For that, we will take the next page. In congruent part, we will take which is triangle? We are taking the ADF triangle. ADF triangle. In triangle ADF. In triangle ADF and triangle BEC. BEC. Which thing you have? First thing, see, first thing you know that ADF angle equal to BCE angle. That symbol, right? ADF triangle, ADF angle is equal to BCE angle. BCE angle. Okay? BCE angle. Then AFD angle equal to BEC angle. AFD. Next, AFD angle. Second part, AFD angle is equal to BEC angle. Okay. Why? Now it is above 2. Already 2. Next, which part is there? Next part is we have to take AD equal to BC. AD equal to BC. So AD equal to BC. Why AD equal to BC? Because these two sides are the opposite sides of the parallelogram, and we know that the opposite sides of parallelogram are equal. Then now we can prove that triangle ADF is congruent to triangle BEC. In which criteria? Why it is congruent? Because angle side congruency. Okay? Angle side congruency rule. We prove that these two triangles are congruent. Now what you got? You got that these two triangles are congruent. Which one? ADF triangle and BEC triangle. These two triangles are congruent. But we have to prove that ABCD and ABEF parallelograms are congruent. Then how we will get the ABCD parallelogram? You can see, if you take ADF triangle and ABCF triangle, when we add these two parts, then we will get the ABCD parallelogram. Like that, when we add area triangle BFC plus ABCF, then we will get ABEF parallelogram. Okay? So, what we will do next? When these two triangles are congruent, then we know that implies we will get that area of triangle ADF is equal to area of triangle BEC. Now this area we already got equal. Now we have to add by adding area of ABCF in both sides. Which area we are adding? See, which area? ABCF, this part. This part. Okay, this part we are adding in both sides. This area we are adding in both sides. Which one? ABCF area. ABCF area we are adding with the two triangles. Okay? When we are adding these two triangles, then what will get? What will get? That implies area of triangle ADF plus area of quadrilateral ABCF is equal to area of triangle BEC plus area of quadrilateral ABCF. In both sides ABCF area we added. When we added ABCF with triangle area of triangle ADF, then you will get area of parallelogram ABCD. Like that. When these two areas are added, area of triangle BEC and area of quadrilateral ABCF, then you will get area of parallelogram ABEF. That's what we have to define for proof. Now, by adding this quadrilateral area in both the triangles, area of the triangles, we got the area of parallelogram ABCD and area of triangle ABEF are equal. Then it is proof. Okay. In this way, we prove this theorem. See first, what thing is given? It is given theorem: parallelograms on the same base and between the same parallel line are equally area. We have to prove that ABCD area and ABEF area are equal. That thing written here: AB, area of parallelogram ABCD and area of parallelogram ABEF. That's what we have to prove. For that, what we prove first? First we prove that ADF triangle and BFC triangle, these two triangles are congruent. After that, we add ABCF quadrilateral area in both the sides. After adding this part, common part in both the triangles, we got the parallelogram ABCD and ABFE. Okay? So now for that we prove that here area of parallelogram ABCD is equal to area of parallelogram ABEF. Okay? In this video we cover how to prove the theorem 1 of the topic area of the parallelogram of under triangles of standard 9. Okay, in the next video we will prove the theorem 2, which is necessary for the 9 students. Okay, very soon, just within 1 or 2 days, I will bring another video. In that video we will discuss about the theorem 2 of this chapter. Next, some questions are there, means maybe 4 or 5 questions are there, which I have also discussed in the videos. And these questions and theorems are very necessary for the upcoming exam for the 9 students. Okay friends, so today that much we discuss. Next video we will bring theorem, how to prove the theorem 2 of this chapter. Okay, thank you students.